All right, so we are checking the assignment from yesterday, and we had 21 through 39 odd. U substitution. Were they all U substitution? Okay, so cool thing today is we have a really chill day. Today is going to be a bunch of stuff up on the boards. We're just going to be working problems. Like, we need to work through some, just need practice. We've gotten the bulk of the material already. There's a little bit left that we have to cover, but let's jump in here. So we're going to check the assignment, and we had started at 21. Okay, I asked you all a bunch of questions like, hey, which ones do we struggle with? And you guys gave me lots of answers, and I don't remember any of them, unfortunately. So you're just going to interrupt me when you need me to stop. Why won't this focus? What? I don't think that has anything to do with my focus. I'm going to try this. Okay, we're going to pause it so that it doesn't, we don't try. What are the options for you right now? What could I pick? So I heard somebody said x squared. Love it. We could try it. Is it going to work? How can you tell? Yeah, when I think about this, here's my whole thought process without writing it first. If I pick x squared, then du is 2x. And I don't see anywhere that a 2x is going to fall out. So that tells me that x squared is probably not the right choice. Give me a different choice. 1 over x. If I do 1 over x, that's x to the negative 1. And I'm already thinking, well, x to the negative 2. So negative x to the negative 2, which I'd get an x squared in the numerator. Is that going to help? Because if I have an x squared in the numerator, it'll divide out with this. Let's try that one. Like, that's the right choice, I think. But time will tell. What was that right choice of u that we just decided might work? 1 over x? Okay, I'm going to write it as 1 over x, but it's going to drive me crazy. So I'm really just going to say u is x to the negative 1, because not a chance we're going to quotient rule this derivative. If u is x to the negative 1, what's du? Negative 1 times x to what power? X to the negative 2. Okay, dx. And then what feels more natural to you guys, to use the du or to solve it for dx and then just see what falls out? Good, that's what I was hoping you'd say, because that's way more natural for me. The book doesn't always do it that way. I pretty much always do. So if we solve for dx, and this is going to get ugly for a second, what do you get for dx? So we'll take little steps here. I'm cool with that. Du over negative x to the negative 2. Anybody look at that and think, yuck? Kalisha, how do we make it less yucky? Love it. Where does that x squared move? What do you mean the other side? So hook it up real quick. Do you recall what happens here? What does it become? Just x? What about that negative? Where does that move it? So careful. I see where the confusion is happening. I think you're giving me the derivative, which is a great thing to give me, but it's not the question I'm asking right here. I did not word that clearly. Just the exponent property itself. And whether it's x or not doesn't matter. What's a to the negative 1? And anybody can help with this. If 1 over a to the first power, right? Like, that's what it means. So when I see this, my first step is, well, let's just make it not as ugly. I think that the negative x squared will go up top and become positive, and then I just have a du. Thoughts there? Do I need to talk any more about the algebra? Okay, so now what? I have no idea what to do. Help. Do what? Okay, so let's actually do the integral now. So this is the integral of e to the what? To the u over, I still have the x squared down here, and instead of dx, this is going to get ugly. I could have a parentheses and negative x squared du, but do you guys agree that that's just multiplying that thing by a negative? It's like I have a constant multiple connected to it. I'm going to do 2 lines of work here with the understanding that I hope you guys do 1 from every point forward beyond this. what comes out of this whole integral? So definitely, it divides out. I agree. Is there anything else that we could move literally outside of my integral? The negative is what I was really after. Both of those things are what we need, but I like it. I don't want the negative in here because it's just a -1 being multiplied. Constant multiples can go where? Out front. Cool. So let's see what this is. We have negative the integral of what's left? E to the u du. And all of a sudden, is there any issue any longer? No, we're golden. I'm going to keep the negative here. What's the integral of e to the u? E to the u plus c. And I'm just going to save one line of work. I just haven't written the plus u. What was u all along? Check it out. And we're just going to confirm this. This was number 31. Okay, let's see if we get it. Is that what we just had? Negative e to the 1 over x plus c? Baller. Where were the issues with it? Just out of curiosity. What did you try? Okay, so good work trying those two things. Remember that you might have to try a smaller piece or a bigger piece. Cool. Awesome. Questions about this problem? Okie dokie. 33, 1/2 the natural log of the absolute value of x squared minus 1 plus c. I don't know how far up we went. 39. 37, gross. Did you guys get negative 2/3? Negative 2 over 3 times the quantity 1 plus root x cubed plus c? Or is this one we're doing together also? Okay. So here's what I think we're going to tweak this with. Anybody in here feel confident on your answer on number 37? Nobody. Cool. All right. Well, good news. Confidence is going to increase because you are all going to solve this problem. So we'll get random groups here in just a second, but I want you guys to go up and collaborate with one another. I want to see your choices of you. You are solving for me the integral, gross, of 1 over, this is 37, right? Love it. Root x times 1 plus root x. And all that's to the 4th power, and we're going dx. All right, we're going to pause this. Overall, the assignment, use substitution stuff. Yay or nay? Okay, so today is honestly just a bunch of board work. Now, it's going to cover just a few things that we did. We're going to introduce a new rule here on this. I want you to, if you want to write down the problems, I'll give us like 5 minutes so you can write down whatever ones you want at the end. I don't want you taking you can take your notebooks up to the board, but I don't want you to take a pencil because I don't want somebody just doing the problem independently on a piece of paper and then saying the other thing. I want you guys to actually talk through it. I'll give you time at the end of class to write stuff down that you want. Deal? All right. So new groups, same groups. Because today is just a bunch of problems. Cool. Let's do new groups. We'll shake it up. I have this thing to do it. Okay, you get one more chance to decide you want the same groups. 3, 2, okay. All right. I'm torn whether I want group of 4 or if I want to make it groups of 2. What's okay? Because I give you 2 options. A or B, yes. All right, cool. These are your groups. Vamos. Group 2, you are welcome to work at the big whiteboard if you would like, instead of the backboard, because there's a little bit more space. Okay, only problem that I'm giving everybody right now is the very first one. I had some printouts, but I don't need them. Okay, I will come around. I don't care if you're using black or not. I think every group wound up with a black marker. I will come around the first group that has an answer here that they're confident with. I'm going to write the second problem up in a different color on their board. Once you finish your first problem, you can ask me, but I won't tell you. I'm going to make you go check with other groups. You will find the next problem with the group that finishes and is confident with the first problem. Deal? Cool, cool. So here is your first problem. And before we start, would any group like to work up on the board? Like with the tablet? Okay, deal. Cool. There's your first problem. Cool. I'm going to pause the recording because we don't need all this time of nothing. So we'll do this.